This video will continue to focus on linear relationships. Our focus is going to be this concept of slope, how we can understand what slope measures and how we can find slope for linear relationships. Remember that a linear relationship is any relationship between two variables that will form a straight line when graphed on a coordinate plane. We see two examples here in blue and in red of linear relationships. Some linear relationships that you worked with in 7th grade are proportional. They start at the origin. Other linear relationships are not proportional. Those are the ones that do not start at the origin. When we talk about slope, we're referring to the unit rate of change for a linear relationship. Specifically, we want that unit rate of change to be written as a ratio in the form y change divided by x change. For a proportional relationship, we can find this information, how much y and x changed by using only one data point. That's because every proportional relationship starts at the origin. So if we look at this blue linear relationship that's proportional, each data point on the graph, the red one, the green one, or the purple one, all by itself could tell us how much y and x have changed by since the beginning of the relationship. If we started at 0 and 0 and the red dot is 2 for x and 4 for y, that tells us we must have gone up 4 units on the y and up by 2 units on the x. If we look at the green data point, we see that the coordinates are 4 for x and 8 for y. That tells us we needed to have gone up by 8 units for the y and right by 4 units for the x. We see that for any one of these data points, if we write it in the ratio y over x, it will tell us the slope, the rate of change. Every time y goes up by 2 units, the x has to go up by 1 unit. When we look at relationships that are not proportional, we're going to need to use at least 2 data points to start determining slope. This is because the graph for a non-proportional relationship doesn't start at the origin, 0 and 0. Because of that fact, the coordinates for one data point are not going to tell us how much y and x have changed by since the beginning of time. Instead, we're going to have to use 2 data points to measure that rate of change, how much y is changing by compared to how much x is changing by. So if we look at this red linear relationship that is not proportional, we see the green coordinate, 6 for x and 7 for y, doesn't mean that y has changed by 7 units while x has changed by 6 units, because we didn't start at the origin. Instead, we started with a y-intercept up here at 0 and 3. Instead, we need to use 2 points, like the blue one and the green data point, to measure how much we change by for y and x, or how much we rise, go up and down, compared to how much we run, move left and right. We see here we'd have to move up by 4 units to get the y from 3 to 7, and we would have to move right by 6 units to get the x value from 0 to 6. We would write that ratio as 4 for a rise, 6 for a run. If we had picked the green and the purple data point, we would get different numbers in our ratio, but the ratio would be equivalent. The rate of change stays constant. We go up by 2 units and right by 3 units. A ratio of 2 over 3 is the same as 4 over 6. This slope tells us our unit rate of change, how much y is changing by each time x increases by 1 unit. In this case, the slope tells us that y is going to increase by 2 units each time x increases by 3 units. That's the same thing as saying y would increase by 2/3 of a unit each time x increases by 1 unit.